Welcome to Learn Fast tutorial. If this is your first time on seeing my video, consider subscribing. Follow my page. Please like and share this video to your friends. In this tutorial, we are going to see how we can simplify this indical equation. So we are going to be working on indices. First things first, for us to successfully simplify this indical expression, we need to have in mind the rules of indices. For us to successfully simplify what we have here, we need to remember the rules of indices. Then we have three brackets 2 to the power of n plus 1 minus 4 brackets 2 power n minus 1 all divided by 2 power n plus 1 minus 2. Now, for us to simplify this, we need to simplify what we have in this bracket, which is 2 power n plus 1. And I also want to remind you that 2 power n plus 1 was actually gotten from multiplying 2n and 2. The product of 2 power n and 2 will actually give us 2n plus 1. This is because for us to have gotten 2 power n plus 1, it means that something of the same base must have multiplied themselves, because when we have the same base multiplying, that's only when we can be able to add the powers. And in this case, the only thing that can give us the power of 1 here is a 2, right? Now, you should not confuse this with when we have 2 power n times 2 power n, because 2 power n times 2 power n will give us 2 power 2n, which is when we add n plus n, we'll have 2n. Now, exactly the same concept in this case. Now, when we have subtraction, you should know that we are dividing whatever we have, right? So we have 2 power n minus 1. It means that 2 power n is dividing by the same base of 2, but in this time with a power of 1, no longer n. Yeah? So that is exactly what it means. So we're going to replace what we have here with this. So, and then we have 2n times 2. Now, exactly the same thing apply here, right? So minus 4 to the power of 2n divided by 2, all divided by 2 power n times 2 minus 2n. So this is what we have. And then you should also remember that division comes before multiplication. So we're going to look for something that we can actually cancel out. And in this case, we have 4 and we have 2 right here. And we know that these are multiplied. So 2 go here, we'll have 1. And when 2 goes there, we'll have 2. So if we tidy up this, we have 3 bracket 2 to the power of n times 2 minus 2 to the power bracket 2 to the power of 2n divided by, then we're going to repeat exactly what we have. And now we are going to see, we're going to multiply out and do not also forget that whatever we are doing here is to make sure that we can, at the end of everything, be able to simplify this expression. So if we multiply 2 and 3, we'll have 6 to the power of 2n, then minus 2 to the power of 2n. This is because we noticed that we have a common factor, 2n and 2n, right? So we're going to multiply in a way that we'll be able to factorize this common factor at the end. So divided by, and we also notice the same factor right here. So we have 2 to the power of n bracket 2 minus 1. Now, in this case, in this denominator, I have successfully simplified 2n out of this whole thing down the denominator, right? Because I have 2 right here and I have 2, and then if I factorize 2n, Remember, we have a subtraction sign, so I need to replace 1 for 2n here, so that when we multiply back, yeah, we have the same 2n. So if we tidy up, then let's factorize for the numerator. So when we factorize for the numerator, we'll have 2 to the power of n, then we'll have 6 minus 2, all divided by 2 to the power of n, then we'll have 2 minus 1. Right, and in this case we can actually cancel this common factor right here, so we are left with 6 minus 2 divided by 2 minus 1. This gives us 4 over 1, which is also equal to 4. So this is the correct answer to this problem. It's quite simple now. When you are solving, when you are trying to simplify this, you watch out for your common factors, and also you make sure you divide, you follow the BODMAS rule. You divide and then before you multiply, right? Now, also remembering the rules of indices. Now, in this case, you can as well say, let's talk about when we have the same power, like in this case, when we have the same power for, when we have the same base and the same power. So it's also the same thing, you know, when we have 2 to the power of n divided by 2 to the power of n, it will give us 1, right? And then if you pretend we don't know that this will actually give us 1, and we decide to do it this way, 2 to the power of n minus n, it will also give us 2 to the power of 0, which will end up giving us 1. So this is the correct answer to this problem. I hope you do understand. Please do not mind anything. What I did here is just to show us how we came about this. So this should not, you should not consider what we have here. This is just me trying to show you from the rules of indices how I actually did this. So you should focus on this, and if you do understand very well, that is perfect. Thank you very much for following on this video. Hope to see you on the next one. Make sure you like, subscribe. If you have a question, you can use this comment section, and see you on our next class. Bye for now.